Good morning to all. In today's class, we will discuss try with multiple catches and also throw. Okay, you know throw is the fourth keyword which will be used in exception handling. You know the five very important keywords in exception handling are try, catch, finally, throw and throws. Okay, first we will complete try catch, that is try with multiple catches. How do we write the program with try with multiple catches? After that I will complete throw also in this class. Okay, now first we will start try with multiple catches. So the syntax for try with multiple catches is like this, we can write. So one try can be followed with any number of catch blocks. So previously we have written for one try we have taken only one catch. So try catch we have written the programs, and using try catch and finally also we have written the programs, and we have written the programs using nested try catch finally or nested try we can call. Okay, we have written the programs on nested try also. Now the last concept is one try can have any number of catch blocks. If you see this syntax, here this is try block. We will write the risky code in the try block, and we will write the handling code for in the catch block. Actually, you know, no. But one try can be followed with any number of catch blocks. That is, this is one catch and this is the second catch. So one try can have any number of catch blocks like this. Not only two, we can write any number. Okay, I can write one more catch. Next, I can write one more catch like that. For one try, I can use any number of catch blocks. I will explain what is the purpose of writing like this. Okay. Next here, one more important point is while writing try with multiple catch blocks, we should follow the order. Here we have to follow one concept. Okay, that is child to parent. This you can easily understand with program. Now try to understand the concept. So while writing try with multiple catch blocks, we should follow the order, that is child to parent. Okay, this I will explain in the program. Okay, next. If we write parent to child, we get compiler error. I will explain this concept also with the program. So I will explain these two concepts with the programs. Why we should write child to parent only? Why can't we write parent to child? Suppose if you use parent to child, what will happen? Like that, we will discuss all these concepts in programs. Okay. So now remember the point, when we write the programs with using try with multiple catches, here the order in the catch blocks. Here inside the catch block as parameter we are writing exception classes now. Arithmetic exception we can write, null pointer exception we can write, array index out of bounds, class cast exception, like that we can write now. So when you write one try with multiple catches, so here the classes order must be inside the catch blocks, not inside the catch blocks. Actually, the parameters of the catch blocks must follow one order, that is child to parent, not parent to child. Okay, I will explain in the program. Next, I will explain the first hierarchy once again. Last class I explained, no? We will revise once the first exception hierarchy. Okay, after that we will see the programs on try with multiple catches. So here this one is very important. Last class I explained hierarchy, no? What is the superclass for the exception hierarchy? That is probable. Okay. Already I explained one more concept. That is, there are two types of exceptions. There are checked exceptions and unchecked exceptions. Okay, what is checked exception and what is unchecked exception? Next we will see with the programs. Okay. see here. We have two types of exceptions in Java, that is checked exception and unchecked exception. So checked exceptions are checked by the compiler for smooth execution at runtime. Okay. Next, unchecked exceptions need not be checked by the compiler. Okay. So first try to understand what is the difference between checked exception and unchecked exception, and which exception classes come under checked exceptions and which exception classes come under unchecked exception. So with respect to hierarchy, that is with respect to exception hierarchy, I will explain the classes for checked exceptions and also the classes for unchecked exceptions. Here I will explain. See, throwable is the super class for all the exception classes. So again, object is the super class of this throwable class. So finally, object is the super class of all the classes. After that, if you take throwable, throwable is the super class for all the exception classes. So this is called exception hierarchy. So here throwable is the super class for all the exception classes or for all the predefined exception classes in the hierarchy. This is predefined exception hierarchy. We are not writing these classes. These classes have been developed by the Java developers. We are not developing these exception classes. That's why these exception classes are the classes which are there in this exception hierarchy. Okay, are developed by Java developers. Now we should know how to use these predefined exception classes which are there in this hierarchy. So this exception hierarchy is very, very important if you want to write number of programs on exception handling. Without this exception hierarchy, you can't write the programs on checked exceptions and unchecked exceptions. Because exceptions are of two types, checked exceptions and unchecked exceptions. That's why to write the programs on checked exceptions and unchecked exceptions, we need to know this exception hierarchy. Using this exception hierarchy only, we should know which exceptions are the checked exceptions and which exceptions are the unchecked exceptions. First, we have to identify, okay, the different, or we have to identify the exception type. We have to see whether that exception is checked exception or unchecked exception. So first identification of the exception is very, very important. Unless you identify the exception type, you can't write the programs using exception handling. Because checked exceptions are checked by the compiler. So checked exceptions must be either handled or declared by the programmer. For that reason, first we should identify whether the given exception is checked exception or unchecked exception. Otherwise, you can't write the program. Definitely, if you write the program without understanding the difference between checked exceptions and unchecked exceptions, definitely if you write a program in exception handling, you will definitely get errors. That's why before writing exception handling programs, first try to understand the difference between checked exceptions and unchecked exceptions with this exception hierarchy table or diagram. This is a tree structure. Okay. First, with this exception hierarchy, I will explain how to identify whether the given exception is checked exception or unchecked exception. That's why this exception hierarchy, that is the predefined exception hierarchy, is very, very important to write the programs using exception handling. That's why try to understand this hierarchy. So for this hierarchy, I have shared separate file in your Google Classroom also. So now we will check in depth. Okay. Okay. Now we will see in depth about this exception hierarchy. All these are predefined classes only. Now I will. Now you know throwable is the, if somebody asks which class is the, or which predefined class is the super class in the exception hierarchy, your answer must be throwable. Don't say object, because object is anyway which is the super class for any class in Java, whether it is predefined or user defined. But if the question is what is the superclass for the exception hierarchy? Means your answer must be throwable. So throwable is the superclass for the entire exception hierarchy. Okay. After that, under throwable we have two subclasses. Means throwable is superclass, no? This is inheritance. Here you can find hierarchical inheritance. Means it is a combination of multi-level inheritance and single level inheritance. So under throwable we have two subclasses, that is exception and error, or other way is error and exception are the two subclasses of the class throwable. That's why throwable is the superclass and subclasses are exception and error. In this level we can say like this. Next we know checked and unchecked. No? We have two types of exception. No? So throwable is checked exception. Why I will explain later. And exception is checked exception and error is unchecked exception. Okay. Next, under throwable we have two subclasses, exception and error. Exception is a checked exception and error is an unchecked exception, and throwable is a checked exception. After that, this is the next level. No? Next, coming to the next level. Hierarchical structure means level wise only we have to discuss. What is the first level in this hierarchy? This is object is there in the first level. Next level is throwable, and throwable is a superclass for the entire exception hierarchy, and it is a subclass of the object class. Okay, first level, next second level, next what is the third level? In the third level we have two exception classes. They are exception and error. Next, coming to the fourth level. So again under exception we have this hierarchy. This is there under exception. Next, again I will explain. Under exception we have the subclasses like this. Okay. So what is the first subclass? Runtime exception. Next is IO exception. Next is interrupted exception. Next is servlet exception. So all these four are subclasses of this class exception. Means all these are four are subclasses and exception is called the superclass. Okay. And one more is there may be any number of subclasses under exception, but these are the important classes which we are using in our programs. That's why here I have written only 4. Don't think there are only 4 subclasses. There may be any number, but these are the important ones to understand the concept. Okay. Now under exception we have 4 subclasses. They are runtime exception, IO exception, interrupted exception, and servlet exception. Next, coming to this point, runtime exception is a subclass of exception. So exception is superclass and runtime exception is the subclass. And runtime exception is unchecked. And one more important point is under runtime exception, this hierarchy is there. So under runtime exception, we have arithmetic exception, null pointer exception, class cast exception, illegal argument exception. Like this, if you see this level. Okay, there is no space, no, that's why I have written like this. Okay, so these are the subclasses under or of runtime exception. Okay, next if you see the hierarchy, again under illegal argument exception, we have number format exception. Under index out of bounds exception, we have array index out of bounds and string index out of bounds exception. And under illegal state exception, we have illegal thread state exception and illegal monitor state exception, like that, this hierarchy. So here, the important thing to remember is runtime exception is the subclass of the exception class. Under runtime exception, we have all these subclasses. Next, one more important point is runtime exception and all its subclasses are unchecked exceptions. So here try to remember this point, otherwise you can't differentiate checked exception and unchecked exception. First we should know the difference between checked exception and unchecked exception. Then only you can write the programs in exception handling. For that reason I am explaining this hierarchy, and in this hierarchy, in this exception hierarchy, runtime exception and all its subclasses are unchecked exceptions. So if you remember like this, only if you remember this part enough to say whether the given exception is checked exception or unchecked exception. So try to focus on only this part. Okay, you need not remember this part. because we can have any more number of checked exceptions. We can't remember all the checked exceptions now. That's why first you remember the unchecked exceptions. So if you want to remember the unchecked exceptions, there are only 18 unchecked exceptions in the entire hierarchy. So if you remember these 18 unchecked exceptions, other than these 18 unchecked exceptions, the remaining exceptions come under checked exceptions. So like that, if one exception class is given to you, then you should be able to tell whether that exception class is unchecked exception class or checked exception class. Okay, so how to remember is simple, very simple. So runtime exception and all its subclasses in this hierarchy are the only unchecked exceptions. Totally these are 18 unchecked exceptions. Okay, other than these 18 unchecked exceptions are checked exceptions. That's why if you by heart these 18 unchecked exceptions, then you can easily identify now whether the given exception is checked or unchecked. That's why please focus on this part in this hierarchy. Okay, after that, under exception, some more exception classes are also there, which are the subclasses of this exception class, but you need not remember all these. It is difficult to remember the checked exceptions. There may be more than 100 also, I don't know exactly, but there may be more number of checked exception classes. That's why you can't, it is very difficult to remember the checked exceptions. For that reason, what I am suggesting is, I am suggesting that you have to remember that only unchecked exceptions. How to remember the unchecked exceptions is, you can say like this: runtime exception and all its subclasses are unchecked exceptions. So totally these are 18 unchecked exceptions. Okay. Now if you take this IO exception, it is a checked. Okay. So here under IO exception, we have exceptions like this. If it is a checked exception, these are also checked exceptions. So next, interrupted exception is a checked exception, servlet exception is also a checked exception. So other than these 18 unchecked exceptions, if you see the remaining exceptions, all these are checked only. Next, exception and error are the subclasses of the throwable class. No, if you take error, here under error is unchecked exception. Under error, we have, these are the subclasses, that is virtual memory error, assertion error, linkage error. Again, under virtual machine error, we have out of memory error and stack overflow error. I will explain stack overflow error. Okay. So stack overflow error means all these are classes only. See, in the entire, in this hierarchy, okay, all these are predefined classes. Like VM error is a predefined class, assertion error is a predefined class, servlet exception is a predefined class, interrupted exception is a predefined class. Whatever classes which are involved in this hierarchy, all these are predefined classes. Error is also a predefined class. Linkage error is a predefined class. Like that, all these are predefined classes. So in this hierarchy, remember only 2 points. First, throwable is the super class, okay, of all the exception classes in the hierarchy. That's why I have written throwable. Next, second important point. Under throwable, we have 2 subclasses. They are exception and error. Next, what is the difference between exception and error? Last class I explained. So exception means the programmer can recover, but error means it is not in the hands of the programmer. Sometimes it may be memory error, like that. No, okay, that's why please focus on exception classes. Next, under exception, we have runtime exception, IO exception, interrupted exception, servlet exception. And runtime exception is the unchecked exception, and all these are checked exceptions. And again, runtime exception is an unchecked exception, which is the subclass of the exception class. Again, under runtime exception, we have these many number of subclasses, and runtime exception and all its subclasses are unchecked exceptions. There are only 18 unchecked exceptions. That's why try to remember all these 18 unchecked exceptions. Other than these 18 unchecked exceptions are called checked exceptions. Why we should remember, I will explain with programs. Next, we will see the programs on checked exceptions and programs on unchecked exceptions. At that time, you can see the difference, how to write the programs using checked exceptions and unchecked exceptions. Okay, that's why please follow this hierarchy. I have taken one more, I have kept one more figure. This is the figure in complete reference. See here in the first table, see Java's unchecked runtime exception subclasses defined in java.lang. So runtime exception is an unchecked exception and all its subclasses are also unchecked exceptions. Already explained there are 18 runtime exception and all its subclass totally 18. No? So here you can see these are the 18. So arithmetic exception. Here in this table, it is clearly mentioned all the 18 unchecked exceptions. So you should remember all these 18 to differentiate checked exception and unchecked exception. So what are these are the subclasses of runtime exception. That is arithmetic exception, array index out of bound exception. Suppose if somebody asks you, check or tell me arithmetic exception is checked exception or unchecked exception. So your answer must be arithmetic exception is unchecked exception. Next, again, if somebody asks array index out of bounds exception is checked or unchecked, unchecked. Similarly, class cast exception unchecked, illegal argument exception unchecked, index out of bounds exception unchecked. Like that, all these are unchecked exceptions, which are the subclasses of runtime exception. So that's why try to by heart this table means all these exceptions. Then only you can differentiate then only you can see the difference between checked exceptions and unchecked exceptions. See, if you see this table, so this is the second table which is given in the complete reference. Java's checked exceptions is defined in java.lang. So all these, whether checked exceptions or unchecked exceptions, all the exception classes are there in which package? Java.lang package, which is a predefined package. That's why to write the programs with exception handling, no need to write the import statement like import java.lang.star, because for all the programs, if you won't import, okay, the java.lang is default import statement which is provided by the compiler. That's why all the exception classes which are there in the hierarchy, all those are available in which package? Java.lang package. That's why no need to write import java.lang.star. If you won't write also, the compiler will provide that statement, okay, for all the programs in Java language. That's why all the predefined classes which are available in the exception hierarchy are there in java.lang package. Okay. Now if you see this table, here class not found exception, interrupted exception, no such file or no such method exception. Okay. No such method exception when you will get is if you won't write main method, but still you are executing with that class name. Suppose class is student, your class is student, but inside the student you have not written main method, but you have saved the file with student.java, compilation is java c student.java, and execution is java student. So during the execution time, JVM will go to the student class and it will search for the main method first. But main method is not available in your student class. At that time, JVM will give you the runtime error and the name of the exception is no such method exception. Means requested method does not exist. You see the meaning also here. Okay. Class not found exception. You have saved the file with one class name, but you are executing with another class name. Means JVM will not find that dot class file for that particular class. In that case, it will give you class not found exception. Okay. All these are checked exceptions. Okay. Similarly, we have more number of checked exceptions. That's why no need to remember the checked exceptions. Try to remember only unchecked exceptions to tell the given exception is checked or unchecked exception. So these are the unchecked exceptions. Okay. So with this exception hierarchy is completed. Now we will write the programs using try with multiple catches. Now you can understand easily. Now understand the difference between superclass and subclass. Exception is the superclass and runtime exception is the subclass of exception class. Again, arithmetic exception is the subclass of runtime exception. You can see multi-level. exception, exception, under exception, runtime exception, under runtime exception, arithmetic exception. So arithmetic exception is the subclass of runtime exception. Again, runtime exception is a subclass of exception. Like that, you can follow all these exceptions. Now I will explain the programs on try with multiple catches. Now here I explained one rule we have to remember while writing the programs on try with multiple catches. What is that rule? Okay, always we have to write inside the catch block exceptions. We have to write the order as child to parent using the exception hierarchy. Okay, if you understand the exception hierarchy, then only you can understand this rule. What is the child to parent and what is parent to child? To understand these points, you must understand the predefined exception hierarchy. Otherwise, you can't follow the programs on try with multiple catches. That's why exception hierarchy is very, very important. Okay. Now we'll start writing the programs on try with multiple catches. Okay. These programs are easy only once you understand the concept. Okay. Class test, inside that I have written main method. So inside the main method, in the try block, here see, if you observe the syntax, here I have written only one try. For that one try, I have written 2 catch blocks. Any number of catch blocks we can write, but in this program, I have written only 2 catch blocks for the single try. Here only one try. Okay. Now inside the try, we have to write the risky code now. Risky code means here I have written like this. String s is equal to null. This statement is perfectly correct and it is executed, no doubt. Next, when you take this statement, that is system.out.println and s.length. So length is a predefined method which is there in the string class, and the purpose of the length method of the string class is to know the number of characters in that string. Okay. Now here what I am trying to do is, actually we should write string s is equal to new string of double quotes Krishna, but without creating the object and without assigning the address of the string class object into the variable s. I am trying to access the length method of the string class using this reference variable. That's why I already explained this. This is nothing but null pointer exception. Why null? Here null is assigned to s, no? Actually the address of the string class object must be assigned to s. If you assign the address of the string class object into s, then in that case with this variable s I can access the methods of the string class. But here without assigning the address of the string class object, I am trying to access the length method of the string class. That's why in this statement error is there. This error is found by the JVM during the execution time. That's why it is called runtime error, which is also called exception. Runtime errors are called exceptions in Java. That's why it is an error in this statement. So when JVM finds error in this statement, immediately from this statement it will come out of the try block and it will search for the matching catch block. Remember, already explained this. Okay. Yet here in this statement JVM finds error. That's why from this statement it will come out of the try block and it will search for the matching catch block. Already you know, no? This is null pointer exception. So it will search for the catch block with null pointer exception only. That is the matching catch block for this error. Next, it will come out of from the try block, and first it will search this catch block whether this catch block is matched for this error or not. Whatever already you know, no? Null pointer exception, like that JVM also knows this is null pointer exception. Okay, like us, JVM also knows this is null pointer exception. That's why it will try for the matching catch block, which is catch block with null pointer exception. But immediately after try block, first it finds this catch block. Okay, first it is null pointer exception, but here it found arithmetic exception. That's why it is not the matching catch block as per JVM. That's why it will not execute this one. Next, it will check the next catch block. Okay, so here null pointer exception is there. That's why it will execute this catch block. This is the matching catch block. which is matched for the exception, null pointer exception. That's why JVM will execute this catch block. Even if you write multiple catch blocks, it will execute only one catch block at a time, and that too it will execute the matching catch block. So that is the concept of try with multiple catch blocks. So what will be the output? Null pointer exception is handled. Okay, because it is the matching catch block. That's why JVM will execute this one. So this is the first program on try with multiple catch blocks. Next second program, class test. Next main method. Next inside the try block, I have written the same exception. See, remember this point. No need to write the same exception in all the programs. Already explained so many exceptions. Means 5 exceptions in depth I have explained. Class cast exception, when do you get, and null pointer exception, array index out of bounds exception, string index out of bounds exception, arithmetic exception. 5 programs I have explained till now. So in place of this exception, you can use any one of those 5 exceptions. Not necessary, it is not necessary to use always this exception. Okay, you can use any exception, but you must write that exception or error code in the try block only. Now again, here I have taken null pointer exception. You know, at this statement, null pointer exception occurs. So from this statement, again the JVM will come out of the try block and it will search for the matching catch block. First matching catch block is for arithmetic exception. So it is not matched with this exception. Okay. Next it will search for the second catch block. One by one only it will search it, but finally it will execute only one catch block, that is the matching catch block. Even if you write 100 catch blocks also, it will execute only the matching catch block. Okay. Now it will see the second one, but it will follow the order top to bottom only. Now first it has verified and it is not the matching catch block. Next it will verify the second catch block. This is null pointer exception, but it is array index out of bounds exception. This catch block is for array index out of bounds exception. So it is also not matched. Okay. Next, finally, this is the third catch block. In this program, I have written try with 3 catch blocks. See, in the final catch block, what is this? Try to understand this one. Exception. Exception already explained in the exception hierarchy. Exception is the superclass for all the classes. So under exception we have, what are the classes under exception we have? Under exception we have runtime exception. Under runtime exception we have arithmetic exception, array index out of bounds exception. Again these are unchecked exceptions. Under exception we have IO exception, interrupted exception, those are checked exceptions. Like that, under exception we have so many exception classes, or all the exception classes are the subclasses of the superclass exception. Means this is the superclass of all the exception classes. If you say throwable is the superclass for the entire exception hierarchy, no, but under throwable we have exception and error, both are there, no. But under exception, if you see, all the predefined exception classes are the subclasses of the exception class. That's why exception class is the superclass for all the exception classes or for all the predefined exception classes. That's why if you take exception, so it is the superclass of which exception? Which exception? Null pointer exception. See here. Here directly it is not a superclass. I will explain here. Exception. Under exception we have runtime exception. Under runtime exception we have null pointer exception. So null pointer exception is the exception raised in the try block, no? Okay. So null pointer exception is in the reverse way I will explain. Null pointer exception is the subclass of runtime exception. Again, runtime exception is the subclass of exception. Is it multi-level inheritance? Yes. So we can say this. What is this one? Null pointer exception is a subclass of exception. Means here if you write exception, it will handle any type of exception. Means all the exception classes are the subclasses of the exception class, no? So if you write this exception class, it will handle any type of exception. That's why I have written at the end. See here, First, it is null point exception. That's why it is not the matching catch block. Next, it is also not the matching catch block. Next, but it is matched. Why? Because exception is the superclass of all exception classes. So it can handle any type of exception. That's why this is the matching catch block for the exception, that is null pointer exception. Okay, that's why in this program it will execute, JVM will execute this catch block, that is what is the output? Exception is handled. See, output is exception is handled. Okay, here if you see, this is a array index out of bounds exception is handled, here arithmetic. Here we can write null point exception is handled, because for null point exception this is the matching catch block. Not only for null point exception, for any type of exception this exception can handle. That's why this is the matching catch block and this is the output. So this is the second program. So already explained, while writing the programs, okay, with using try with multiple catch blocks, you should follow the order, that is child to parent. So that's why child classes. What is the parent class here? Exception is the super class or parent class. So the order must be, so while writing the try with multiple catch blocks, in the catch blocks, we should follow the order, that is child to parent. This is arithmetic exception is the child class for exception. Next, array index out of bounds exception is the child class for exception. That's why first write the child classes, followed by at the end write the super class, that is exception. Here in place of this exception, you can write runtime exception also. Why? Because already explained the hierarchy. First exception, then under exception runtime exception, under runtime exception null pointer exception. That's why in play this runtime exception is the super class of null pointer exception also. So in place of exception, you can write either exception or null pointer exception also. Correct? You try in the lab. Here you can try not null pointer, runtime exception also you can write, because exception, then runtime exception, then null pointer exception. So what are the super classes of null pointer exception? Okay, what are the super classes of null pointer exception? Runtime exception is a super class of null pointer exception, and also exception is also a super class of runtime exception. That's why when you want to write the parent class, write either exception or runtime exception. Okay, that's it. If you write here runtime exception also, you will get the same output. That is, this is the matching catch block. That's why exception is handled. So here if you observe, we have taken child to parent. So this is child, this is child, this is parent. Okay, that's why this order we should follow while writing the try with multiple catch blocks programs. Okay, otherwise what will happen? Here this program is executed now. This is child, this is child, this is parent. This order only we have to follow, child to parent. That's why here parent we have written at the end. That's why the output for this program is this is executed and exception is handled. Next, what is the other way? Suppose if you write parent to child, then what will happen? Already explained, you will get compile error. Okay, how we will get compile error, I will explain in the next program. So here we have written perfectly, because I have taken first child classes, followed by at the end I have taken super class, because exception class is the super class for all types of exceptions, whether the exceptions are checked or unchecked exceptions. Now next program is, I will write parent to child. Okay, now same program I am modifying, test main method. So inside the try block I have taken the same exception, that is string s is equal to null, s dot length. Here in this statement error is there. That's the name of the error is the name of the exception is null pointer exception. Next, from this statement the JVM will come out of the try block and it will verify or search for the matching catch block. So it will come out of the from the try block. Now it will check one by one. First, this is the first catch block I have written now. Now here catch exception E. So this is the already explained. This is the super class of all checked exceptions and also unchecked exceptions. null pointer exception is an unchecked exception. So for null pointer exception, the immediate superclass is runtime exception. Again for runtime exception, the next superclass is exception. So exception is the superclass of this null pointer exception. So exception can handle any type of exception, already explained. That's why the matching catch block for this is this one. So here this is executed actually as per our idea. This is the matching catch block. That's why your output will be exception is handled. But it is not correct. You will get compiler error. Why? Because suppose here, first I will explain like this. So it is null pointer exception. So this is the exception can handle now. That's why our answer will be like this. But it is not correct now. Why? I will explain the reason. Next, what I have written the next catch blocks. This is arithmetic exception I have written for this catch. This catch block is for arithmetic exception, and this catch block is for array index out of bounds exception, and this catch block is for null pointer exception. Actually, this is the matching catch block now. Our exception is null pointer exception, and here exactly matching catch block is there. But the JVM will not execute this matching catch block. Why? Because as per the rule, exception is the superclass for all the checked and unchecked exceptions. So all the exceptions are handled by this exception. That's why immediately first JVM will execute this one. But actually it will not reach to the correct matching catch block. This is the correct matching catch block. But already explained, JVM will execute only one catch block for one try. It cannot execute more than one catch block. Once it finds the matching catch block, okay, or after execution of this matching catch block, it will not just go for, it will not see the remaining catch blocks. Directly after executing that matching catch blocks, it will come out of the main method. This is the end of the main method now. Means it cannot see this actual matching catch block is this. It cannot see this matching catch block. Why? Because already in the first two we have written exception. It can handle any type of checked and unchecked exceptions. That's why immediately it will execute and it will come out of the main method. That is the drawback of this program. Because here, suppose in place of null pointer exception, I will write the code that is for this arithmetic exception. Let us write here system.out.println 10/0. So 10/0 is arithmetic exception. Again, from that statement, it will come to this first catch block, and this can handle any type of exception. So arithmetic exception is also handled by this catch block. Next, if you write string index out of bounds exception, that will also be handled by this catch block. If you write what are the other array index out of bounds exception, the code for array index out of bounds exception. Again, this is the matching catch block for that exception also. If you write class cast exception, again this is the matching catch block for that. Means if you write any exception here in the try block, whether it is checked exception or unchecked exception, so all the exceptions, okay, which are occurred in the try block are handled by this first catch block only. Means what is the use of writing all these catch blocks in this case? So this catch block is enough no to handle all the exceptions. Okay, so it never, JVM will never reaches or will never execute or will never check the remaining catch blocks. Always for any checked or unchecked exception, this is the matching catch block. That is the drawback of this program. When you write parent, this is the parent and these are the child classes. So arithmetic exception is the subclass of exception class, array index out of bounds in the subclass of like this. So even this is this catch block, it can handle any type of exception which is raised in the try block. So JVM will never reach or will never see the remaining catch blocks. That's why here if you write like this the program, then you will get compiler error. So here this is the compiler error. Exception java.lang.null pointer exception has already been caught. Has already been caught means actually this is the matching catch block, no exact matching catch block. But here already the first catch block handles the exception. No, that's why here the error is like this. It will give you this fully qualified name. Okay, this is java.lang.npe, because null point exception is our actual exception which is available in java.lang package. That is the fully qualified name has already been caught. You will get this type of compiler error. That's why how to overcome this is when you write this catch block at the end. Here if you write the catch block at this end, then here matching catch block it will find, no. Then if you write the catch block for exception at the end, then this will be executed. Means this is the exactly matching catch block. When you write at the end, if it will not find any matching catch block, then it will execute the catch block with exception, because exception is the superclass, it can handle any type of exception. That's why always write the catch block with exception at the end only. If it finds the matching catch block, then it will execute. If it won't find the matching catch block, then it will execute this last catch block, that is for exception. So that's why you should follow child to parent only. This is parent to child order. If you write parent first, any type of exception is handled by this catch block only. It will not execute the remaining catch blocks. That's why even it will not check the remaining catch blocks. Once it finds the matching catch block, from that catch block, it will come out of the main method. So that is the drawback. Next last program is, we will see what is this program. So here class test, inside that I have written main method. Again I have written null point exception, we will see. So here arithmetic exception. So here null point exception. No? So it will come out of the try block. It will first see this first catch block. But here a null point exception, here arithmetic exception. So it is not the matching catch block. Next it will search for the next catching block. It is array index out of bounds exception, that is null point exception. So this is also not the matching catch block. Next there is no catch block. So when there is no matching catch block, even if you write more than one catch block, then again it is a compiler error. In this case also you will get compiler error. Okay. Saying that the error is, it will give you null pointer exception error. So because there is no matching catch block for this null pointer exception, we have written multiple catch blocks. What is the use? So writing the catch blocks is not at all important. Writing the matching catch block is very, very important in exception handling programs. So with this program, so here you will get error because there is no matching catch block. Okay, so you can see the output in the lab. Okay, so try to execute all these 4 programs. With these 4 programs, you can understand the concept of try with multiple catch blocks more clearly. Next, after that, we will see okay. Now I will explain throw keyword. 4th keyword, no? So this is the 4th keyword. Okay, we have only 5 keywords. Next class I will explain throws. Okay. What is the use of or purpose of throw keyword is? Throw keyword is mainly meant for customized or user-defined exceptions. Already explained, there are 2 types of exceptions, predefined exceptions and user-defined exceptions. Predefined exceptions are designed by the Java developers. User-defined exceptions means we have to write our own exceptions. Suppose if you go to ATM, okay, you want to draw 5,000, but money is there only 1,000. At that time, error only, no, you will get one error, no. So that type of errors are called insufficient funds exception. Let us take, you are trying to draw 5,000, but money is available, that is only 1,000. So in that case, it has to give one exception or error, no. So which type of exception? Let us take that the name of that exception is insufficient funds exception. So that is called user-defined exceptions. Like predefined exceptions, in the hierarchy we know predefined exceptions, no? So like predefined exception programs, we can write user-defined exception programs also. Because this program, for this program, we have to design our own exception classes. But predefined exception classes like arithmetic exception, string index, out of bounds exception, all those predefined classes which are there in the hierarchy, they are developed by the Java developers. So we can write the programs in two ways in exception handling. We can use the predefined exception classes programs to write the exception handling programs, or we can write our own user defined exception classes. So exception classes we can write on our own also. I will explain one program using this user defined exception class. We have to write our own class. Like example is same. If you want to draw 5,000 but 1,000 is there, then you have to get error, no? It will not give you 5,000, no? So what is that error is, inside that ATM, they have kept that Java program. Okay, using this exception handling only. That's why you are getting one error, no? That error is nothing but this exception. Okay, so this type of exceptions are called user defined exceptions. We can create our own exception classes. Programmers can create our own exception classes. Those are nothing but user defined exception classes or user defined exceptions. So the main purpose of throw keyword is, okay, throw keyword is mainly meant for customized exceptions or user defined exceptions. Customized or user defined, both are same. Predefined or customized. Next, but in using predefined exceptions also we can use throw keyword. Now I will explain how do we use throw keyword in case of predefined exceptions. When you write the programs using user defined exceptions, there again we will discuss this throw keyword. That's why throw keywords, even though the purpose of this throw keyword is in user defined exceptions we use, but in predefined exceptions also we can use. Here I will explain how to use the throw keyword in case of predefined exceptions. That's when we want to write the programs, okay, using user defined exceptions. There again I will explain the purpose of throw keyword. So you can remember like this. Throw keyword can be used either in predefined exception handling programs or user defined or customized exception programs. Okay. Now here, what is the purpose in predefined is, let us here you read one statement, simple only. We can create exception object explicitly and hand over to JVM manually. Already explained default exception handling procedure. No, there are five or six steps are there. No, there I have explained one concept, that is, in which method exception is raised, then that method is responsible to create that exception object and hand over that object to JVM. Means the method is handovering the object to JVM. Okay. In contrast to that, here what I am doing is, I am creating the programmer is creating the object explicitly using throw keyword in the program and hand over to JVM manually. So this is the concept. So using throw keyword, the programmer is creating the exception object explicitly and the programmer is handovering that object to JVM manually. Okay, if you understand the default exception handling concept, then only you can understand this program. Otherwise, you can't understand. That's why default exception handling is very, very important. Now, in default exception handling, in which method the exception is raised, then that method is responsible for creation of that particular exception object and handovers that object to JVM. Means that method handovers, that method creates that object and handovers that object to JVM simply. In place of that, here what we are doing is, the programmer is creating the exception object manually and handovering that object to JVM. That's it. Their method is method is creating the object and method is handovering that object to JVM. But here the programmer is creating the object and the programmer is handovering the object to JVM. That's it. Only that is the difference. Okay. Using throw keyword, the programmer can create the exception object okay, and hand over to JVM manually. That is the advantage of throw keyword in case of predefined exception handling programs. Now I will explain. This is without using throw. Without using throw, you can understand this easily. Class test inside the main method. Here 10/0. This is default exception handling procedure. So here without using try means we have to apply the default exception handling procedure. In case of default exception handling, the main method, inside the main method, this exception is raised. That's why main method is responsible for creation of this arithmetic exception object with the information, name of the exception, name of the exception, description of the exception, and stack trace. Already explained clearly this program. Okay, in default exception handling. So after that, main method is creating this object. Okay, and main method is handovering this object to JVM. This is the program on default exception handling without using throw. Now the same program here you will get error. No, you know the error also already explained this one. Now the same program I am writing using throw. Now this is using throw. So class test main method throw. This is the throw keyword. After throw, you should write exception class object. Any type of exception class object you should write. Means what does it mean? We are creating, means the programmer is creating the exception class object using throw, and the programmer is handovering this object to JVM. That's it. In the previous program, main method is creating the object and main method is handovering to JVM. But here when you use throw, so here exception object is created by the programmer using throw keyword, and programmer is handovering this object to JVM. That's it. Okay. Now here throw, after throw we should write only what we should write only exception class object. So you know how do we create an object using new operator? No. So new name of the exception is arithmetic exception, and this is parenthesis. Inside parenthesis I have written the description of the exception. If description is not there, then only simply write parenthesis, because for some exceptions descriptions are not there. Only for some exceptions descriptions are there. So it is description is optional. That's why it is for arithmetic exception description is there, that is divided by 0. Now this is the object which is created by the programmer and using throw keyword. So when you write like this, what is the meaning of this statement is programmer is creating the object arithmetic exception class object using throw keyword, and the programmer is handovering this object to JVM. After that, the same procedure, whatever procedure we followed in default exception handling, no, the same procedure is applied here also. Even though it is an error only, same output you will get. Output also same, because it is default exception handling procedure only, but only who is creating the object and who is handovering the object to JVM. Only that's it. Okay. Now the output will also be the same. The previous program output, if you execute previous program output, and this output also same. Their main method is creating and handovering to JVM. Here programmer is creating the object using throw keyword and handovering to JVM. That's it. Next one, last important point in throw is after throw, if you write any statement, then those statements will not be executed. We get compiler error saying that unreachable statement. After throw, here throw, no, after throw if you write any statement like after try, inside the try block after the exception, if you write any statements, those statements will not be executed. No, like that here also after throw if you write any statements, those statements will not be executed and you will get compiler error. So with this throw is completed. Okay. Next, these are enough, or I will explain one or two programs later. Now with this you can understand the concept of throw keyword. So with the throw, I am creating an object and I am handovering this object to JVM. That's it. After that, again it is a program on default exception handling only, but only difference is who is creating and who is handovering to JVM. After that, with that object, JVM will apply the same procedure, that is default exception handling procedure only. You will get the same output whether when you execute the previous program and this program. This is one use of throw keyword in predefined exception classes. Like that, in user-defined exception handling or user-defined exceptions, again we use throw keyword. Okay, at that time I will explain the second use of throw keyword. Okay, so with this you can understand throw keyword. Next class I will explain throws.